Okay, hi everyone. Welcome to meetup organized by GDG Wrocław, and today Renan Araujo will talk us about perks and compromises of Flutter desktop. You can ask questions in the comments on YouTube. At the end of the talk, we'll just bring questions one by one, and Renan will answer them. And two most active participants to most accurate questions will uh, get ability to win the JetBrains license. It's 1 year, one product license. Okay, so Renan, the stage is yours.
Thanks. Thanks, Carol. Thanks for this. So let's get started. Yeah. Hello there. My name is Renan Araujo, as Carol said. And today I'll be sharing a little bit of an ongoing experience in developing an actual desktop app built entirely with Flutter. It's still in progress, so I'm very excited to share everything in details with you. But presenting myself first, I live in the city of Porto, Portugal, and I work as a software developer. And as a software developer, I worked recently, more recently with Flutter, but before that with a web front end. Besides that, I have been using Flutter inside projects since 2017. And in all of these years, I have worked in some open source projects, for example, PhotoView and Flame, which I'm wearing the shirt today. And I work for this company called Rose. And one of our current initiatives is to build a desktop app. But it's not any desktop app, it's a spreadsheet app. So a little bit more about Rose, about the context in which the things I will share today about Flutter were learned from. So let's give a quick look, I promise, a quick look in what the product is first. Okay, so Rose is a low-code platform that allows people build connected apps through a spreadsheet user interface. So, for example, from a cell formula, you can perform HTTP requests like get, post, and put. It's possible also directly from a cell formula connect to services like Slack, Twitter, and even email. And also it's possible to automate tasks to run requests or any kind of computation, even if the user is nowhere near the computer. Even though the desktop app is a pretty new initiative, Rose is already rocking the field with this web app for some time now. It's already in production, and you can access it on rose.com. So we can use this very mature product as a glimpse of what our app may look like in the future, and we can have a better sense of the challenges ahead. So talking about challenges, our goal is clear. It's to build the next generation spreadsheet app. But if we are going to aim for this kind of challenge, we have to first address everything that everybody expects from any spreadsheet platform and any spreadsheet app. So even the most basic things and the list of features and kind of interactions creates a huge, extensive list of things that we have to do. So understand the challenge. From the start, we need a table, obviously. So there's a lot on this statement of needing a table, because editing a table requires a flexible yet very performance effective UI, because a table can vary in size. So a table can be very small, like 5 columns, 5 rows, and that's it. Or it can grow a lot. I'm talking about hundreds of columns and thousands of rows. having so much content, it's clear that we may overflow the user's viewport, the screen or the window. So yeah, we need scrolling. It's a very important part of this challenge, and the list goes on. The list goes on, and it's a lot. We can have millions of cells. Do the math. We may have hundreds of columns, thousands and thousands, thousands of rows. This results in a huge number of cells. And each cell can contain lots of kinds of data, like text, numbers, dates. Yeah, there's a lot inside each cell. And besides that, we can have formulas inside a cell. And talk about formulas, we have to support editing formulas with text highlights, code highlights, and autocomplete selections, multiple selections, and the list goes on and on and on. And if we are going to cover everything that a spreadsheet app has to cover, we will be taking literally days here talking about features. But I think it's enough. This is enough to understand how demanding the product is in terms of performance and user experience. But where does Flutter joins this equation? So yeah, we all know that Flutter is awesome, and you probably heard about how great it is to develop using Flutter, due to its amazing developer experience and how the results are usually really good. For example, we have plenty of cases of stories of people using Flutter on mobile apps, from small corporation to big corporation to small startups. And you probably either know someone that can share their stories, or you are that person that can't stop speaking about Flutter. So if this person, or in some cases you, are like me, they can speak nonstop about Flutter for hours, and that's called Flutter fever. It's okay. The symptoms usually show up sometime after the first hello word. So yeah, I have it. It's awesome. It's okay to have it. So anyway, the point is, Flutter has proved itself as an awesome option for app development in the mobile world, at least. Differently from other multi-platform toolkits, it includes a vast collections of widgets, not just the basic ones, but some complex ones. Through Material and Cupertino libraries, it's possible to start off from zero to building pretty screens without much hassle. So widgets like this ones, Material, Bottom Sheet, and Cupertino Context Menu, they really help you to go from scratch to a native-like approach pretty fast. But when it comes down to desktop apps, what's the deal? How is this whole environment? So let's finally talk a little bit about Flutter Desktop. But before that, before diving deep into Flutter Desktop, a disclaimer here. As everybody knows, Flutter Desktop is not the stable channel, and it's not completely done yet. So it's under a flag, if I'm not mistaken. And since it started way after Flutter Mobile, I think it's kind of unfair and unreal to expect the same level of maturity as we see on mobile. So I will not focus on stuff that's not ready because of that particular factor, but instead I will focus on how stuff that's fundamental to Flutter, intrinsic to desktop app development, may affect somehow your app development process, as a point of view of a Flutter developer today, that in most cases is used to deploy to mobile screens, to small screens. So yeah, we are done with our introduction. Sorry for the 25 slides long. But let's finally talk about perks and compromises of Flutter Desktop today. So let's start by the good stuff. Everything we know and love about Flutter. Okay, so first one of them, of course, Dart. Yeah, Dart. We have Dart, obviously. And developing a desktop app with Dart means you have a new safety, and you count on reliable and fast products built using Flutter. That's the same as we know from mobile. And also, going for Flutter Desktop, we inherit the tooling. The tooling is amazing. We all know if you worked with Flutter before, we know that things like the dev tools can really help the debugging process. Also, another perk inherited for Flutter is hot reloading. Performance is already great, but when you have hot reloading, you can change any part of your application and see instantly in the app itself, and you don't have to rebuild every time. So this is another thing that we got from mobile, and we don't see much on desktop app development. So it's really great to have this. I'm talking about performance. Performance is great. It's already quite amazing. Especially if you're talking about macOS, it may improve with time, even more on Linux and Windows. But it's also it's reliable already, so we can feel the same fluidness of user interfaces, animations, and stuff like that, as we already see in mobile devices. And last but not least, these three things that we don't get much on desktop app development: cross-platform, declarative UI for desktop, and it is for desktop. So we don't have these three together too much. The only other place that I can remember that's you can have this is using a modern JS framework, like, for example, Vue or React or something like that, a declarative UI framework, using together with Electron. So this is one option. And another option of a modern declarative UI framework for desktop is SwiftUI. But these two were actually the two options that we at Rose had alongside Flutter for picking to build our desktop app this year. And this leads us to this very important subject: why we chose Flutter in the first place. The thing is, we may have sheets with potentially millions of cells. We don't want to be held back by UI painting. Electron uses WebView, so it's not a native canvas, and in some cases, performance-wise, it may not be an option. SwiftUI is amazing, and I love to work with it for some weeks in the start of this year. And I actually endorse any Flutter developer out there who has access to Mac to try SwiftUI a little bit, just to learn a new technology. It's really, really great and resembles so much Flutter. But it's not cross-platform, and our purpose is to provide computational power to everyone. So we decided to go cross-platform. So yeah, that's why Flutter for us was of course the best option. Okay, so Flutter is amazing. Okay, it's all fun and games. It's great. Flutter Desktop, it's perfect, right? No, time for the real stuff, the interesting part. And I know that most of you that are here today is for this part, is the compromises, or which after some time thinking, they are more like challenges. So yeah, we can call them as challenges as well. So I'll call them as compromise/challenges. And we may take things as granted when we are talking about Flutter Desktop. So usually those compromises and challenges are things that we take as granted, as some things that we don't need to worry about, but sometimes, and this month's of development prove them to be a big of a deal after all. And they are screen sizes can scale up and down. So when you are on a mobile, developing for mobile, you are if you are any Android, you can have a range of screen sizes, but they don't vary so much as they can vary on desktop app, because we have window mode on desktop apps, and the user can resize the window. If you don't clamp the size, the user can go from a mobile size window, and if the user has a 4K monitor, which can scale up to that resolution using our app, maximize it to full screen, can make some difference in the experience of our app. So you have to be prepared to all of these scenarios and adapt your app to be on the necessary scenarios. So from the other aspect of this is going from touch to mobile plus keyboard. There's some changes there as well. Scroll wheels can be way more complicated. I will explain in a little bit about this statement. And keyboard shortcuts now matter. Yeah. First of them, screen size changes. This may sound an obvious change and may not be a big of a deal for people, but in some cases, it's not actually a big of a deal. But anyway, changing the viewport to your app make a lot of difference in how a UI works. It's beyond building a responsive UI. We may rethink not UI only. We have to think of the structure of your widget tree, because we can have changes on the user flow. For example, in the shopping app, if you open a cart, the user opens a cart, it's almost as always redirected to a cart screen. So it's essentially navigation that you have there. You are changing screens. But on big screens, we may have room for things like floating panels, where this user can interact with it without leaving the main screen, basically. And the decision to adapt your app or not for big screens is totally up to you or whoever is deciding things about your app. But we can take a look into a little bit about the philosophy of Flutter and how they're following stuff there, and maybe this can inspire us to try to adapt to all platforms. So the thing is, we have different platforms. Cross-platform is the idea of going and running stuff across all of them. But every platform has its particularities, and most of them have a common area of experience in which most multi-platform, cross-platform frameworks takes place on. So most cross-platform frameworks always mostly aims to the common area between platforms, and it's like the user, every user of every platform has a similar experience between platforms, and they don't take advantages of the particularities of each platform. But since I got to look into a little bit into the inner workings of Flutter, I can say that that was never the philosophy of Flutter. It's always always supporting everything about each platform, so each user has a good experience regardless of which platform it is, and there is in most cases APIs for things that are particular to some platforms, like you can have user gesture detectors that can accept gestures from a stylus key, from a stylus pen. and have detects the force of that pen and stuff like that. And these things are not available on most Windows devices and Android, but it's a common thing on iPad. So this is the kind of the thinking that we can bring into our to our UI development, to our app development. So we can provide a good experience, a great experience in our platforms, and adapt ourselves to not be an extraneous thing that runs everywhere, but a good thing that runs in each platform and take advantages of each place. Yes, this was kind of more of a philosophical thing, but we have a very concrete problem when going on big screens, and it's performance. Let me explain. Yeah, everything is great when you have a scroll page like this one. It's like very small on a window mode or a window screen, mobile screen or a window mode, and it's possible to take advantage of something from Flutter that's called Flutter's Sliver Protocol that allows a lazy loading of content on scroll. It's a long name. I just call it lazy scrolling. And it's basically the idea of laying out and painting stuff only once they enter the viewport. So you can only worry about widgets that are rendered in the screen at a time, not anything that's off screen. So this makes the performance not depend on the whole book of content, but just the things that are on the viewport. And in this case, for example, it's an example of a usage of a spreadsheet app. It's basically a window when we have like about 100 cells in the viewport each time. But if we grow up and if we scale up the things, this is a 1440p resolution, and the app is running in full screen mode on a macOS, and we have 1,300 cells in the viewport at the same time. So things are getting bigger and bigger and bigger, and this is already a problem because if we have if you think in a widget tree level, and if each cell is a widget, we having this amount of cells that's iterated every widget build. It can be a problem for your animations and screen refresh rate and stuff like that. But things can get worse. So let's suppose we go 4K screens. This is the amount of cells we have on a 4K resolution, so things can scale up quickly. Even though lazy loading does that performance improvement for us not to depend on the whole bulk of content, we still depend on the viewport size, which, as we saw, desktop apps can scale up as resolutions gets bigger and bigger and bigger. So it's something to have in mind that 60 frames per second that we have almost granted on Flutter Mobile may be affected here. So keep in mind that. Solution for this that we found for this was to make each cell as a widget, but not rebuild them on every rebuild type. But we keep them, and in the elements tree, we keep them the widget children of cells, and we only compute the cells that are in the diff. So cells that entered the screen and cells that left the screen. So in this GIF, we have in certain frame we have sometimes that shows green and red cells. The red cells are the one that went away and were discarded by a scroll frame, and the green ones are the ones that enter the screen. So these are the only ones that are built and recomputed, but the ones that had no change didn't go through any kind of transformation So yeah, they are just repositioned in the render object level. Yeah, that's basically it. Another problem is changing paradigms of interaction. In other words, from touchscreen to mouse plus keyboard. So it's the problem is basically this. It's a long known issue that human fingers and cursor pointers are different from one another. For example, the human figure is by nature imprecise, and it's large, it's big. So when you touch the screen, you probably covering some part of the content, while cursor pointer is very precise. And other thing is we can have multiple taps, multiple fingers in the screen at the same time, while in a cursor pointer we just have one. Also, scrolls are not via drag on desktop usually. I know there are desktops hardware today that have touchscreen, but in most cases, the largest amount of cases, it's mouse plus keyboard. So we scroll with the mouse wheel on mouse, and on touchscreen you have to drag. But this was a change that came recently to Flutter. It is today on Flutter desktop. Scroll views are not scrolled with drags, with mouse drags. Mouse drags are not accepted by scroll views on Flutter by default. But yeah, that was a recent change. We actually had to go for a workaround during that time, but this is fixed right now. So this is something to think about, to have in mind, that we can't have scroll views that rely on drag, unless we have to rely on drag, things like a page view or something like that, but we can always adapt our code. And also we have on cursor pointers, we have the secondary button. So it's basically a context menu. So when you click with the secondary button on the mouse, you open context menu, while in the touch screen we have long press to context menu. In desktop, we almost never have long press. So yeah, those are things that we have to adapt when going from mobile to desktop. And also the idea of the cursor never leaving the screen is something that brings another state for widgets that we may need to address, that is hover state. So yeah, we have hover, so we can take advantage of that in some ways and sometimes. Yeah, an example of how is different interaction between touch and mouse is Microsoft Office has actually a touch mode on its apps. So it's basically for some of the Windows hardware that supports touchscreen. It just provides a better experience for people that are using their fat fingers instead of a mouse, of a very thin and precise cursor, mouse cursor. That's basically it. Another thing is, remember these two guys I presented you before, the context menu and bottom sheet for Material and Cupertino. It's basically it's really hard to give actual use for widgets such as these ones on desktop. We may need alternatives. We may need to rethink some part of the UI. So things like this may make you have to refactor a little bit your widget structure when porting a Flutter app to desktop. Possible solutions. Yes, there are some projects that add desktop fluxed widgets to the large pool of options that we have to make our lives easier. Namely macOS UI and Chicago. These are two good packages to give a look at. And more on this subject, you can watch the building a desktop design language with Flutter on the latest Google I/O. It's on YouTube with this title. And there's also the Aero package that allows material-based apps to look like Ubuntu apps. It's really good. And yes, this one is it's really complicated. Yeah, scroll views can get more complicated on desktop, and yeah, by that I mean there's an unspoken rule on mobile UX development that states one shall not scroll content in both axes. You have to pick one. So when you talk about bidirectional scrolling in a mobile app, you may get these reactions basically, but yeah, I know that there are exceptions. There are places that having bidirectional scrolling can be a viable solution. And one of these cases is, guess what? Spreadsheet apps. So we need a lazy scrolling in both axes. And this means is the very idea of a spreadsheet app is to spread content in multiple directions, in multiple places, and most times we have to scroll to reach them, to reach this content. And as we can have millions of cells in a bulk of content, we can't handle all of them at once. So we have to use slivers. We can't use something like interactive viewer that kind of scrolls in two directions, but they're not actually scrolling. They don't use the scrolling machinery of Flutter. They are just translating content. So yes, we have to go for slivers basically, and sliver to the rescue. Yeah, not completely. With slivers by itself, they're not built for two-dimensional scroll. So I will explain this right now a little bit. So how slivers work. This is very related on how slivers work. So yeah, this is a very brief on explanation. This is a subject for hours. So I'll try to go on shallow waters here, and you can research and look a little bit more on it. There are the Boring Show and other videos that can help you about slivers itself. But how they work basically, we have the good and old realm of box widgets. So what are box widgets? They are widgets that are dependent only on their size and the size of viewport, basically. It's about, it's like every widget, center, text, column, row, and flex, and stuff like that. Basically, most widgets that don't scroll content, they are basically box content. So yeah, every app starts from the start of the tree, mature app and scaffold and stuff like that. Every app starts with box widgets. And when we create a list view, a grid view, or even a custom scroll view, any scrollable view on Flutter, they contain this special thing called viewport widget, which is, in my opinion, one of the most important widgets in the entire framework. The viewport widget is described by the Flutter API documentation is the workhorse of the scrolling machinery. So it's basically builds, it contains a sliver, so every direct child of viewport has to be a sliver widget, which is a widget that depends on scroll variables, as opposed to box widgets that depends on its size and stuff like that. So the viewport controls its slivers with these two classes, sliver constraints and sliver geometry. Sliver constraints is a way for the viewport to tell each sliver its constraints. So this constraint contains information that's capable of answering questions like, am I, so this is the point of view of a sliver, am I on the viewport? So for how much am I occupying of it? So how much I was scrolled by? While geometry is a way for the sliver answering to the viewport things like what are the information that the sliver computed from the constraints. So how big that sliver is, or in which pixel that sliver decided to occupy, and stuff like that. So this is how the viewport composes a scroll view. And well, the problem is that these two classes, geometry and constraints, they don't carry enough information to have lazy loading of content, lazy scrolling in two axes. The sliver protocol entirely was made with mono directional scroll in mind. So the solution, I think it's pretty clear. We have to hack the viewport and accept two-dimensional sliver shortcuts structures, and we factor the entire sliver protocol. Okay, this is pretty easy. And the next easy thing is to recreate all sliver widgets in the framework. There are too many of them. I'm not risking a number, but there are too many of them. And some of them are very important. We use it by almost anyone who uses Flutter. And yeah, even if these widgets don't use two-axis scroll, we will have to basically recreate them, right? Now, the solution we came up with was it was way simpler yet effective. We nested the scroll views. So yeah, one thing I forgot to tell about is we may have up to 5 tables in the same page. So every table has to be a sliver. And yeah, we set the outer scroll view, the vertical scroll view, to create a sliver to box adapter. So it creates a realm of boxes inside the sliver realm. And each of these tables has an internal horizontal scroll. So you basically have, in other words, scroll and lazy loading of cell in both directions. And the other thing is, yeah, no, it's basically it. We have this. This is basically the result. I don't know how is the frame rate on the stream, but it's 60 FPS here, basically. And the last but not least challenge / compromise is keyboard shortcuts now matter. Because when the user is interacting with a touch device, it's possible only to interact with elements that, for obvious reasons, visible in the screen. As a result, we have a very clear and sometimes explicit user interface that describes actions as regions. But on desktop apps, we most times have this device. It's persistent physical buttons that can be pressed even if the application is not necessarily and explicitly expecting. So sometimes it's very convenient and in some cases mandatory to provide ways for the user to perform actions using keyboard shortcuts like Command Z, Command A, and things like that. So yeah, Flutter provides the shortcuts API. It's a fairly recent API, and it's basically providing interface to declare the different shortcuts and map them with intents and actions that this app will take given occurrence of this keyboard shortcuts. And yeah, that's basically it for compromises / challenges. And I'll talk something about I'll talk some stuff about things that I said I didn't I was not going to talk about. There are things that are not ready yet on Flutter because of its state of development, but can be a deal breaker for you. So if you need multi-window support, and this is something that you can't start with, I would say to wait some months to start with Flutter Desktop, because multi-window support is not there yet. So we can have we can have changes this in the future, in the near future, but right now, today, there is no support for this. Also, if you rely too much on Material and Cupertino to build mobile apps, you may have some problems with desktop because, as I said, some of the widgets just don't work on desktop. Not they don't work because they have a bug, but they don't work because it's not very appropriate for a window interface that we have. We almost as always have on desktop. And yeah, also building plugins. So we can have times that we need to interact with the platform, and there is no plugin for that particular reason in the pub package store yet. But most times we end up writing it. So for Android and iOS, we have languages like Kotlin and Swift, but on Windows and Linux today, the only way to building plugins is using C++. So know where you are going at. Yeah, it's basically a warning. And text editing. Text editing is still some particular things that we are very used to on editing text fields on desktop apps using mouse and keyboard. They just are a little bit weird right now on Flutter, but this is being changed very fast. So recently we had something like double click to select a word, for example. We didn't have this on Flutter until recently. So these are kind of the micro interactions that we don't have on Flutter right now. And yep, that's all. That's basically all. Oh yeah, we are hiring.
Yeah, thank you, Renan, for the great talk. Yeah, if anyone have questions, please ask them on the YouTube comments. In the meantime, I have one question. You mentioned plugins.
Yes.
So is it common that plugin that which is commonly needed does not exist for desktop?
No, most of them, like shared preferences, for example, it's a good example. They already have support for all platforms possible: Linux, Windows, macOS, etc. But these are mostly the ones built and maintained by Google. There are lots of others that are maintained by third parties, and I can't assure that all of them, how many of them have versions for Windows, and even less for Linux. But for macOS, it's Swift, so it's basically most things I can risk to say that we work as much as like on iOS, and that's basically it. I had to write a plugin for managing window, for example, for not letting the user to resize the window for less than 300 pixels wide. Yeah. So this was in Swift, but when we go to Windows and Linux, it will be a problem. We will have to write on C++, but only on Windows we have the Windows 32, which is a fairly good documented platform, basically.
Okay, thank you. I don't see any questions, so we give away licenses on the next event. There's a question. What is your personal preference for Flutter navigation? Is Navigator 2.0
yes.
navigation system or library?
We are not quite decided on that particular matter, but as far as today, we are going with navigation 1.0. For most cases, this is, I think it works fairly well, and the API is fairly good, but there are its problems. That's why we have navigation 2.0. But I tried navigation 2.0. I didn't understand why this exists and why we're having this idea yet. But we need a very declarative navigation library that I don't think this is the prettiest part of Flutter, but yeah, as far as today, we are going built-in, not a third-party library, Navigator 1.0.
Okay. Okay, we don't have more questions, so Thomas, please reach me. So I will give you a license, and yeah, thank you again, Renan.
Nice. Thank you.
And everyone, stay tuned for the next announcements. We plan the next event also about Flutter, GDG Wrocław. Yeah, so please observe our YouTube channel and Meetup and Facebook. Okay, so
Thank you.
Thank you, Renan. Bye.